All right, so this is the second lesson in our Unit 10 on circles, and we are going to look at what a central angle is, major arcs, minor arcs, semicircles, and then we're going to find their measure, and then we're going to find their lengths, and these are totally two different things. Measure is degree, length is actual length, so it's a distance. So when we're doing this today, make sure that you don't measure or mess those two up. And so central angle is what we're looking at mostly today, and central angles come from the center. So this would be a central angle. So would this one be a central angle? We're going to talk about different types of arcs, major, minor, and semicircle. And then we'll look at congruent arcs and adjacent arcs and arc length. Again, arc length is different than arc measure. So our central angle always add up to be 360. So all these angles together is 360. So if I know half of them, I know this is a diameter, then that would be half of 360 or 180. So here, finding x, so we've got to see we don't have all the angles around, so we can't put these all equal to 360. But if I look at here, this is a diameter, so those are going to all equal 180. So I would put 8x minus 4 plus 13x minus 3 plus 5x plus 5 equals 180. And then add up my x's. So 26x minus 2 equals 180. Add 2. 26x equals 182. And then take 182 divided by 26. So x equals 7. So we're looking at those measures. We're going to also use that relationship to find what an angle is. All right, so this one is similar, and you can go ahead and work that out and find that. Find x. So that leads us to arc measure. Arc measure is the same as the angle measure. So if I'm looking for arc AB, it would measure the same as the angle measure. So if this angle measure is 60, then my arc measure is 60. Also, any arc that is less than 180 is a minor arc. And we name minor arcs, usually we use 2 letters. We don't have to, and then we put a little arc over there to tell you we're talking about arc and not straight lines. A major arc is anything greater than 360, and that you do have to do 3 letters. So you're going to tell the person where to start, to go through, and where to end. So this is arc ADB. It's greater than 180, so it's a major arc, and we have 3 letters. Otherwise, if I don't have 3 letters, I choose the shortest distance, and I would pick AB. So that's the difference between the major and minor. Now, sometimes minor arcs can be named as 3 points. So don't just look at and say, well, it has 3 points, so it's major. Also, if my arc is 180, then it's called a semicircle. So we're going to look at identifying the arc and then finding its measure. So x, z, y. So it is a semicircle because it's half of the way around. And its measure is the same as this angle measure, which is 180 degrees. All right, WZX is a major arc because it's greater than half. So we're major. And its measure is, we know that this is 90, so if I take 360 minus 90, that will tell me this. So 360 minus 90, 270 degrees. So its arc measure is 270. So again, I'll let you work through those other examples, and if you have questions, make sure you're coming in and asking and getting that figured out. So if I have two arcs that have the same angle measure, then they're congruent arcs. If the arcs are congruent, then the angle measure is the same. So here, we're going to look at this, and we're finding the length of KL, or the measure, not the length, of KL. So we see that this is 21% of the whole distance around. So if I find 21%, or 0.21, of 360, that will tell me that arc measure. So 75.6, which is the angle measure and the arc measure. We'll do one more of those. NJL. So we want this whole amount, so everything but the 16%. So I'm going to find out what angle measure is 16% of 360. And then that will tell me what this angle is, and so I can take that from 360 to find that whole, what the angle of the arc is. So we get 57.6, and then I'm going to subtract that from 360 because that's this measure of this angle. So this angle has to be 360 minus that. 302.4. And I'm going to let you go ahead and work those out. And we're going to go to the next part. We can add angle arcs together. So if I wanted to find the measure of LHI, I see that this is 90, so this has to be 90. So it'd be 90 degrees. All right, let's go to our last section, and we're talking about arc length. So we know how to find the total length around. That's the circumference that we found yesterday. So what we're going to do to find arc length, if we just want part of it, we need to know what fraction of that part we have. So we take the angle to find that fraction of the angle measure. So the angle over 360 gives me what fraction of the circle I'm looking at, and then we'll take that fraction times the circumference. You can also set it up as a proportion, so we'll look at both here. So we're finding the length of DA. We know our angle is 40. If we didn't know that, we'd have to find that, and we know our radius is 45. So you can go 40 over 360 times the circumference. So the fraction times the whole way around. So we know what fraction of the whole way around it is. So 2 pi r is my circumference. And I can just, multiply the top there and divide by the bottom. If I wanted to, I would reduce that to 1/9, 9 pi. My 9's cancel, and I get pi, which is equal to 3.14. Just so that I can do that without calculator. All right, so if you have any questions, again, that should be everything. Have a good day.